In this problem, I'm going to analyze the forces that act on an object when it's on an incline. So I'm going to draw an incline here, and I'm going to say the angle of the incline, theta, is equal to 30 degrees. And I'm going to draw an object on the incline. In this first example, I will not have friction. It will be a frictionless surface, or basically mu will be equal to 0. Frictionless surface. The mass object, I'll make 10 kilograms. And what I want to solve for is, if I place this object on the incline, what will be its acceleration rate? So I want to find the acceleration rate of the object as it goes down the incline. So the first thing is to draw an FBD. So we draw our object and we make sure we draw it at an angle. So I'm going to draw the object. And I'm going to draw it elongated or rectangular in the direction of motion, so I'm not confused as to which one is which way is which. Since the object's going to go down the incline, I'm going to tilt the axes. This is my new x-axis, and this is my new y-axis. And with that, I have the one component of gravity, mg sine theta, and then I have another component here, mg cosine theta. Notice how I draw it at the center of mass. The forces originate at the center of mass with arrowheads. And then Fn, the normal force, drawn at an angle perpendicular to the surface. And so without friction or any other force, those are the three forces that are acting. Step 2, sum of the forces. So I'm going to draw my positive x-axis this way, and my positive y-axis this way at an angle. And so in the x direction, I have one force, mg sine theta. And in the y direction, I have Fn minus mg cosine theta. Next box is acceleration equal to 0? No, it will accelerate, so I just X it out. In the y direction, is there acceleration? No, that is 0. There's 0 acceleration in our x direction. It will not accelerate up or down, only along our new x-axis. So these are the equations that we built based on our free body diagram. So step 3, solve, is to solve for acceleration. So I basically have this equation right here that I've built. And so for the solve part, I can come up here and say mg sine theta equals ma I. And you can see here the masses cancel. So my acceleration is g sine theta, which will be equal to 9.8. Remember from the last video that we just put in the magnitude here, okay? Sine of 30 degrees, which I believe is a half. So this is about 4.9 meters per second squared, I. So we're going to follow the same format as an A-force problem. We draw a free body diagram. This is an incline problem, so we're going to tilt the XY axes. We're going to fill in the template in the X direction and the Y direction. Ask ourselves if the acceleration is equal to 0. If it is, we put 0. If it's not, we cross it out. And then finally, we do step 3, solve, which is taking the equation or equations that we've built based on the FPD, in this case just the first one is all we need, to solve for the acceleration. And again, when we plug in numbers for g, it's the magnitude of g, 9.8. And our answer is 4.9 meters per second squared.